So I think we'll move on to the first panel now, and it's really my great pleasure to introduce Ventakesh Narayanamurti, also known as Venki. And I'll just say a few words about Venki. It's great to have him here, and then I'll invite the panelists. Actually, we can have you come up if you don't mind, and take a seat. So just very briefly, Venki is the Benjamin Pierce Research Professor of Technology and Public Policy at Harvard. He's going to kick off our panel discussions. He'll be talking about, he'll be addressing the topic of technology and innovation. That's our first panel. And Venki is credited actually with developing the field of phonon optics, and is currently active as well in the field of semiconductor nanostructures. He's served on a number of national and international advisory panels. He's an elected member of the National Academy of Engineering, the Royal Swedish Academy of Engineering Sciences, American Academy of Arts and Sciences, a fellow of the American Physical Society, and so on. You get the picture. Very, very distinguished career thus far. And he worked at Bell Labs. He may touch on that a little bit. He also served as Dean of the College of Engineering at Santa Barbara, and then importantly served as Dean of the Harvard School of Engineering and Applied Sciences, and oversaw its transition from a division to a school. In a few months, he has a book coming out on cycles of invention and discovery, and I highly recommend. From what I've seen, looks like a very interesting manuscript. So I'd like to welcome our first panel on technology and innovation. And Venki will...
Well, thank you very much, Jessica, for that wonderful introduction. You outdid yourself. And also, congratulations to everybody at TPP. You should know I'm passionate about two things, engineering and technology. And the other thing I'm personally passionate about is linking it to change policy. So, hopefully, this can be an interesting discussion. And I'm really glad Jessica and Noel chose technology and innovation as the lead panel. So every one of these are important. Education, we're going to discuss it. Education is actually near and dear to my personal heart. And Jessica has assembled a really outstanding panel for this. So we'll follow the procedure which Jessica and Noel had sent me. I'll introduce the panelists. Each of them will speak for 15 minutes. Maybe I'll give you a warning at about 12. And then I will say a few words of some of my own thinking, depending on what and then hopefully we can open it for a wide discussion. So that's sort of the procedure. We really have an outstanding panel. I even knew some of them because of my recent past. And first, I would like to introduce Erika Fuchs. She is a professor in the Department of Engineering and Public Policy at Carnegie Mellon. It's probably a close cousin of this program in some ways, and Granger Morgan was head of it for so many years, and I visited CMU a couple of times recently and really been kind of amazed with what they do. She is, of course, extremely well known for her work on the role of government in public policy, and I think that's an important issue because, in fact, it's so related. And I know I've read some of her papers, especially how DARPA is supposed to run, and has made a personal impact. She was recognized by the World Economic Forum as the best 40 young scientists under 40. So you know she is not just a rising star, she's a star. The second panelist is actually somebody I got to know when I went over to the Kennedy School, actually, after I stepped down as dean. And she's Kelly Sims Gallagher, who is professor at the Tufts School and, of course, for many years at Harvard. Kelly is one of the pioneers at Harvard. She actually was the founding director of the Energy Technology Innovation Project along with John Holdren. And I think I benefited personally a lot from the foundation she had laid with that project because some of it came to fruition here. The other thing which I'd like to mention about her, she is not only an expert, especially in clean energy technologies, but she's also really one of US's experts on China. And in fact, a year and a half ago, she went on leave from Tufts as special advisor to the Office of Science and Technology Policy and Special Advisor to the State Department on China, and I think she does get significant credit for laying the foundations for the US-China agreement in 2014, which President Obama and Xi Jinping signed. So I think the important element is she actually brings complement his expertise to Erica, especially, even though Erica herself has also worked a lot on China, but really the international landscape in this important arena and where technology might play a role. The third person in the panel brings an entirely different focus. Again, entrepreneurship is a very important element of technology innovation, and she is, I would say, both Harvard and MIT can take credit for her. I hadn't realized she's actually a graduate of the then Division of Engineering and Applied Sciences, and she is now, of course, Professor and Dean of Innovation, Associate Dean of the MIT Sloan School of Management. She's very well known for her work on innovation and management, and so I think it actually will give us a balanced view, I hope, from our three speakers. So first, I'd like to call on Erica to say a few words.
So I can't imagine a greater honor than coming back to your own institution and having or your original home birth institution and having the opportunity to speak. So it's just a delight to be here today. And I'm going to do that thing of, they gave us a couple of questions, and I'm going to go, no, I didn't like the questions. I'm going to sort of try to sort of answer the questions in a slightly different way. And I think this stems from a belief with which I want to start, that there are a series of policy problems where the technical details matter. So I start this whole, anything I say from here forward stems from that belief. I don't think all policy, it is not that all policy, the technical details matter. By all means, there are plenty of policies made and needed that don't need engineers at all. But I think there are a set of policies where the technical details matter, and because of that, that really, rather than asking the question of what methods we should ask first, I would want to ask the question of what are the real world problems where the technical details matter. So that's where I want to start. Where are the problems in the world where the technical details matter? And so then I think the question is, how do you find the right methods to answer those questions? And also, how do you support students in inventing new methods to address those problems? So with that said, I think that there are some foundations or some fundamentals with which we need to start. The first is, who are you talking to and what has been said before? Invariably, you're going to be in a conversation with others. And so there probably are foundations, not just in terms of how you approach the problem, but others who are saying things in economics, in political science, I would argue in history and sociology, as well as the engineers or the scientists who are out there in the real world. And so, for example, in my own work, when very early on coming here out of technology and policy, economists had trade theory, which suggested that when you changed manufacturing location, what you were going to do is make the same thing in the US versus in China, and you just might add more capital in the US and more labor in China, but it was still going to be the same widget. And what working with technical details and engineering methods enabled us to do is show that when you moved from the US to China, you didn't actually have economic incentives to make the same thing. You were going to make something different instead. And so you didn't only change the manufacturing location, and you didn't only change how much it cost or how much labor you were putting in China versus in the United States. You also changed what you were making and the technology decisions and technology trajectories of those firms. So there, without being able to speak the lingua franca of the field, which is economics, you wouldn't have been able to have that conversation. So that said, I think you also need to be able to find the right methods, as we talked about, and invent new methods. So first off, I would think that there's a list of methods that are necessary that you need foundations in. And I'm going to list them here. The one would be qualitative methods. So qualitative methods let us say, is there a surprise that we wouldn't have seen with quantitative methods? What is the process by which things happen? And how do things come about? Quantitative methods, I think you also need. So I've had the fortune in my career to collaborate with econometricians and statisticians. And I would say that each of those, what they think is a legitimate model varies depending on who you're talking to in those fields. And likewise, all of my students take Introduction to Computer Science. Many of them take data structures. Many of them take machine learning. And indeed, with the expansion of data at this point in time, that becomes an important part of being able to address the problems facing our world today. So to kind of have those as foundations becomes important. And I even want to bring back in terms of machine learning, there is, so right now I am fortunate to be launching an institute on the future of manufacturing. And in that institute, we're taking machine learning and looking at how we can leverage machine learning to accelerate the scientific discovery process and its introduction into new commercial products. But one of my favorite statements is from one of the machine learning experts themselves. They gave this example where there was a DARPA competition, and they were trying to identify what was a tank. So this was a machine learning algorithm to identify a tank. And they thought they had the perfect machine learning algorithm. So they kept showing, once again, every single time it showed a tank. And then suddenly the machine learning algorithm showed a tree to be a tank. And of course, this is for the military, so the intent is if it's a tank, you're going to shoot. And it turned out what they had instead of a perfect machine learning algorithm to identify a tank is they had a perfect machine learning algorithm to identify a sunny day. Because every time they trained the machine learning algorithm on what was a tank, it had been a sunny day. And so the machine learning algorithm turned out that it was very good at identifying sunny days, whether it was a tree or a tank, and not so much good at identifying the actual tanks. And so the point here is not that, for a matter of fact, the institute I'm launching is using machine learning to accelerate scientific discovery and its introduction into new products. So it's not that machine learning is faulty, it's that there needs to be a conversation, right? This is so obviously the next thing you have to go out and do is start training that data to also identify tanks on cloudy days, right? And not just on, but you have to have a constant conversation going back and forth between what you're doing, identifying the how, the process, and also then testing. So in many ways, the qualitative work lets us say, if we identify new hypotheses, can we use quantitative data to inform or to test that hypothesis? And finally, I think if you do believe that there are policy problems where the technical details matter, it is the scholars' discipline then, if they're engineers, is their technical discipline. So in my own case, I come from material science and engineering. That's my training and my background. So it's your technical background that becomes your specificity and where you're going to be adding to the conversation as you are trained in these complementary areas. So I think that to sum this up, I'm fortunate right now to be serving with Kelly on the innovation dialogue that John Holdren is having between the Minister of Science and Technology, or as an expert guiding the innovation dialogue between John Holdren and the Minister of Science and Technology in China. And I think one of the things that came about, and again, to come back to what is the importance of qualitative methods, in that area, my expertise is really in manufacturing and in technical decision-making in materials. And so in that context, manufacturing is not the ideal area to try to establish collaboration between the US and China. It's not, for each nation, there's so much challenge in terms of whether that be national security or economic growth, that's not going to be the area to open up communication. And so it was really going out and interviewing people across the country who I happened to be friends with, and then going back and actually having Kelly and John say, we need to bring in more of the policy here. We've got too many technologists on there, and going out and interviewing another set of people and figuring out what there was, the technical details, but having a scientific enough background to be able to talk to the technologists, talk to the people in policy, and know they're also their lingua de franca, whether that be engineering on the engineering side or economics or political science on the political science side, to be able to bridge that gap and try to and to bring that all together. And I will say, Venki, I hope, I can only hope that we aspire eventually in collaboration to yet another great outcome in a second year. So, no.
Thank you very much.
Yeah.
We'll have discussion of all of it at the end of the presentation. So I'd now like to call Kelly Sims Gallagher from Tufts University to say a few words.
Thanks, Venki. Good morning, everyone. I too feel deeply honored to be here, a person from the Fletcher School over at MIT, especially since I'm not an alum. But I've always felt sort of tangentially part of this family through the years, and it's great to be part of this celebration today. And congratulations on reaching 40 or 41. So my background, as Venki mentioned, is very much in energy technology innovation. And I've come at it from a social science perspective. So I'm one of those few people, I think, in the room probably that is on the social science side of that hill, the Granger Morgan hill, that's climbed the hill and tried to learn as much as I could. And even in graduate school, I remember taking classes over here at MIT to try and improve my technical understanding about automotive technology, which was what I was focusing on for my doctoral work. So just with that perspective, I wanted to give you that sense of where I'm coming from with these remarks. And I think because, as Venki mentioned, I just spent 15 months working in Washington in the White House Office of Science and Technology Policy, the question that Noelle and Jessica posed to us that most animated me was the one about the role of the research community in policy, since I just had a sort of deep dive experience going from academia into policy, and thankfully coming back out, still alive. So just what I worked on there was to mainly serve as an advisor on the negotiations that were ongoing between the United States and China on a climate deal. And I was there. We got the deal much faster than expected. So in the first 6 months from when I actually got to Washington, we were able to get the deal by November. And then we actually were able to do a second deal in last September 2015. So I had more time than I expected. And so I ended up doing a lot of other things too. I ended up coordinating the US-China Innovation Dialogue, which is associated with the Strategic and Economic Dialogue. I managed the Climate Data Initiative for the US government. I conceived and constructed a new public-private partnership called Climate Services for Resilient Development. And I also engaged in a lot of bilateral discussions with other countries in the run-up to the Paris Agreement, because, as many of you may know, at that time, we were working with many other countries to construct what was known as the INDC, the Intended Nationally Determined Contribution, which was basically what each country was committing to in advance of the Paris Climate Agreement. So I really had a chance to apply my knowledge to a lot of different areas, some of which I was much more comfortable with and familiar with, most notably the US-China discussions, and others where I really felt like a relative novice, the Climate Data Initiative and data science, which I had done virtually no work on. I mean, I had used data, but that was like, that was it. And even though I've been working on climate change policy and technology for almost 20 years now, I realized, and preparing these remarks, I really had not worked very much on the adaptation and resilience side, and that ended up being a really major focus because, ironically, I knew more about it than anybody else who was there, and that is going to be one of the comments that I make. So I just wanted to make a few observations about my time in government and what it's like for someone who cares about technology and public policy to go and try and serve in government. And the first observation is that prior knowledge is invaluable. And all of the time that you're spending studying, researching, acquiring and developing and honing expertise is your currency once you get there. And then once you're there, it all starts depreciating. So you go downhill immediately. And there's almost no time to actually do research when you're there. And I think maybe we're in a very particular moment during the Obama administration where you're especially cut off because of concerns about hacking and cybersecurity. So for example, the entire time I was in the White House, we could not click on a link. So if people did manage to find me and find my email in the government and send me a new study or an important paper, they almost invariably would send me the link and not send me the attachment, but I couldn't click on the link. So I just felt so closed off from all my normal information channels. I also, of course, didn't have access to my Tufts email, where you realize you've just got information flowing to you constantly to keep you up to date and current. So whatever knowledge you have is extremely important. It gives you the ability to answer questions right on the spot, to have a clear and confident reaction when you're asked for an opinion. It allows you to suggest good ideas when there's an opening for them. And I think most importantly, to shoot down bad ones, and for good reasons. And over, I just felt like in many meetings, I had that knowledge and so many other people didn't have that knowledge just because they had not developed expertise in this area. Not that I'm smarter, but just they didn't have the same set of expertise. And this leads to my second observation, which is that there are many generalists in the government, and probably necessarily so. These people have to be able to move around into a lot of different positions, but very few of them have a deep expertise in one or more areas. So even modest knowledge about a topic can make you the top expert. So the fact I had published one paper in Nature Climate Change on adaptation was why I got landed the climate resilience portfolio. And to me, I felt like I had barely dipped my toes into the water, but there it was, oh, she's published a paper, she's the expert, let's have her do it. So it really can give you the responsibility to handle an issue. And then all those skills that you've acquired about how to learn, how to quantify, how to do back of the envelope type calculations are so important because it allows you to handle new issues and learn on the spot. Now turning to some of the challenges, while I felt highly valued within the Office of Science and Technology Policy itself, and certainly by some of the most senior members of the administration, I also quickly realized that expertise is not necessarily highly valued by many other people in the government. And this was really tough. Sometimes I really did know something about the topic that was on the table. And it was very hard to get my opinions or voice heard because it was considered not appropriate. I was out of my swim lane. I was told that many times, you're out of your swim lane here, sort of get back to where you belong. And that was pretty challenging, and I think probably the most frustrating thing. And relatedly, people will then try to pigeonhole you on one topic to keep you in your lane. So The third sort of tough thing is that your knowledge can even create enemies because you have the ability to outshine them because you've got those answers on the spot in meetings, or you have the ability to scuttle initiatives that others have dreamed up because you can point out why they're wrong so easily. So despite these real and serious frustrations, I come away from the experience convinced that government needs many more people with scientific and technical knowledge, and here I include people from the social sciences too, working there. There are too many people in charge of domains that really don't know anything about those domains, and that was really painful for me to watch while I was there. And on the plus side, presumably you're passionate about the issues you're working on, and so having the chance to actually do something very concrete rather than publishing a paper or teaching a great class, but getting a very concrete result, practical real-world result that can make a difference immediately is immensely satisfying. And as frustrating and hard as the experience was, I'm so glad I did it. For me, having spent many years slogging through China, trying to learn Chinese, spending a lot of time learning about the technology for climate mitigation, really felt like it had all paid off, and that being able to contribute to this US-China climate agreement felt like the culmination of the first 20 years, first half of my career probably. So what I really wanted to say to all of you is, if you do get the chance, take it. And for all of you department chairs or deans or would-be someday deans, let those people go, because they would be, I think, providing a great service in whatever government that they're serving, and will come back so much richer for that experience. With my remaining few minutes, I did want to also pick up another one of the questions that were posed to us, which was the characteristics of TPP as a research domain, and relatedly, what are our research priorities looking forward? And this session's devoted to innovation, so I wanted to make a few observations about the innovation domain. And again, I emphasize my perspective is very much rooted in the innovation for energy and development perspective. I think, I teach a class on innovation at Fletcher, and I always struggle with how to teach that class and how do I describe the evolution of this field. And at least the way I understand it is that our real study of innovation systems, I think originated mostly out of the economics profession. And major advances were made by notable economists that we've all read, like Joseph Schumpeter or Kenneth Arrow. But many of the innovation economists still consider themselves to be shunned by the field or ignored by the field, and not central to understanding the role of innovation and economic growth. And that's interesting that we're still in that position today after so many years. And then I think also what we should recognize is that numerous rich and canny insights have emerged from really diverse disciplines: sociology, history, engineering, of course, physics, and more recently, I think, social scientists who are studying the behavioral dimensions of the innovation process. So my point here is, I think as we look forward, we need to just be very forthright that innovation studies require an interdisciplinary approach, and we really need to have greater openness to the contributions that various types of fields can contribute. I also think our understanding about the role of policy in innovation systems is still relatively weak. It's so rare to actually read a good, solid evaluation of a policy intervention designed to stimulate or spur innovation. It's hard to do that. Governments don't want to fund that kind of research, but in fact, it's really important. The government plays an enormous role in the innovation system, and so I think this is a big gap that we need to work on filling. And that's one of the research priorities I would emphasize going forward. Another would be to invest more in the social sciences and to encourage more social scientists to engage in innovation studies. My own work on technology transfer has revealed to me over the years that most of the barriers actually are not technological, but are really social barriers. And another example I can think of from the energy domain is that DOE recently commissioned this study on the cost of solar and why DOE wasn't able to get to its target for the Sunshot Initiative. And they discovered that the soft costs of solar, customer acquisition, licensing, permitting, financing, and generally getting the last mile, are much greater now than the hard costs here in the United States. And according to DOE, those soft costs can equal up to 60% of a solar home system here in the United States. And furthermore, most interestingly, US soft costs are much, much higher than soft costs anywhere else. So those are all social questions that actually lead to the ultimate, what we think of as technology costs, the cost of a solar PV panel sold in the market today. And then the last, and I know I'm out of time, the very last area I wanted to mention is non-US, non-OECD innovation systems. Much of my work recently has been on the globalization of the energy technology innovation system, and that was the focus of my last book. And I think we need to recognize that for a complex set of reasons, the innovation system has really gone global. We're way beyond national innovation systems. And I think countries around the world are making significant contributions, and in particular, non-OECD countries are making very important contributions to global innovation systems. That's certainly true in the energy domain, and I would wager it's true in other sectors as well. And I think that is a much more neglected area than it should be, and another area for future research. And with that, I'll stop. Thank you.
Thank you very much. I'd now like to ask Fiona to say a few words about.
All right. Well, thank you very much, and I really appreciate the opportunity to be here this morning. My background, as Venki mentioned, is I started in basic sort of science and research. My undergraduate and master's degree are in chemistry, and then I found my way over the pond from the UK to the US, and I've ended up at Harvard in the then division of applied sciences. One of the things that was very particular to me, to my experience, was that I had an advisor in Peter Rogers who was somebody who, see, Venki doesn't know that either. There are all these things that you're learning about me today. One of the things that Peter encouraged all his students to do was to go and take classes in the economics department and policy down at the Kennedy School, and even, dare I say it, to venture over to Harvard Business School. And so I became increasingly interested in the policy context and the role of incentives and policies in really shaping the direction and rate of technical change. So today I find myself at a School of Management, and the fact that I have slides for my presentation will just be a dead giveaway for the fact that I'm a business school professor and can't really go anywhere without some PowerPoint. What's so striking to me, particularly at MIT, is that in our management school we have a tremendous number of people who are extraordinarily interested in and engaged in policy. So even though, in some senses, organizations and firms are the unit of analysis that our students come to learn about, in fact, a lot of us do a great deal of our work understanding the policy context in which those kinds of organizations really operate. And so that's very much the world I live in. I would also just say, and to pick up on this point about policymakers and being in the government and being a generalist or a specialist, is when I finished my PhD, you've changed the mic, is that right? Okay. When I finished my PhD, I spent a little time thinking about what I wanted to do next, and I went back to the UK and thought I wanted to go and work for the British government on issues of technology and policy. And when I got there, they said to me, well, you have a PhD in something quite technical, and you have a degree in chemistry, and we only really hire generalists. And in fact, if we did hire you, we'd specifically put you in a department where any of your specific technical skills would not be used, because you'd sort of bring a bias to your policy making and to how you'd advise the government, and we really don't want you to do that. And so I found that a little bit perplexing, and as I say now, I think that was a lucky decision for me, because I've ended up here at MIT, which has been quite extraordinary. I have in some sense got my own back, because I now sit on the British Prime Minister's Council on Science and Technology, and so I have the opportunity to engage in bringing some of my expertise to bear on that, and that's been a very interesting experience for me. The area of technology and policy that I really focus my efforts on is really what I'd call innovation policy. And basically what I mean by that is sort of how we create a more systematic understanding of the factors that shape the innovation process. This is something that, as Kelly said, economists and sociologists and others have spent a lot of time thinking about, but to really sort of ground that in a deeper understanding of the phenomena, I think, is extremely important. Groups like the National Science Foundation, through their SciSip program, have been extremely supportive of this kind of arena, but it certainly does draw very strongly on an economics tradition and on folks like Nate Rosenberg and others. And in really taking this direction, we sort of think about things at a variety of different levels. So we might want to understand this at the project level. So, how do we think about the selection of innovation projects? The program level, what programmatic interventions really make a difference? Or the regional and national level, so how do specific policy changes really change innovation outcomes? And I should say that for the purposes of this, when I think about innovation, I would define that as that sort of process or continuum by which ideas move from the earlier stages of conception all the way to impact on the economy. Now, I recognize, and we could all agree, that there's no linear model of this process, but nevertheless, it is a process, and we can identify the things that shape it. I think that one of the things that has been extraordinarily important in allowing us to make progress in this regard is actually the development of new data and metrics. Because I would say that traditionally, one of the challenges that we face is really the limits to the kind of information we have. And we end up with this kind of complicated trade-off that I know Erica thinks about like I do every day, which is you kind of want to get into the weeds of the details of the particular innovations. And yet, if you want to make generalizable statements in large data sets, you have to abstract away from that. And so I think that's always a continual tension. And many of us in this field do work, I think, in the way that Erica and I both do, which is to kind of get deeply and understand the specifics through qualitative studies and then abstract up from that to try to find the best quantitative metrics. Just a few of the kinds of things that we've been doing in some of this is thinking about an entrepreneurial quality index. So quite often we want to think about whether firms and organizations are doing more in terms of ideas with high potential. That's been some really interesting work driven by my colleague Scott Stern. We've been looking at different samples. So with Ed Roberts, I had the opportunity to do the second round of the MIT alumni survey with him, which gave us a really different population of individuals, right, all matched on getting an extraordinary MIT education to understand their activities. A lot of my early work was trying to link patents and publications to very specific scientific artifacts, whether that's human genes, transgenic mice, and so on. And so really getting into the details of the process has been very important. I think there are also some methodological advances, which certainly to my mind come driven out of the social sciences, particularly this rather experimentation-oriented approach that I think have allowed us to make a lot of progress, but which do have implications for training. And so I think sort of online and laboratory experiments sort of coming out of psychology and behavioral economics have been important. Sort of natural experiments and the econometric infrastructure that goes with those natural experiments that allow us to exploit changes in the policy environment, and even organizational experiments, but making sure that we compare the treated and the untreated. And so these kinds of things, and taking that more experimentation-oriented lens to innovation policy, I think has really driven a quite significant rewards. And so I just wanted to give an example of each of these based on my own work, but by no means am I the only person to do this. These are just the examples I know best. So for example, at the program level, one of the questions that we became very interested in was this whole issue of bias and gender bias in the innovation process, particularly in terms of participation and funding. At the highest level, the policy questions really are to do with the pipeline of women in the labor market as innovators, as entrepreneurs in STEM, and so on. At the sort of micro level, if you like, this study was sort of driven to really ask the question whether there were biases in the funding processes. This is a hard thing to think about, and so we took inspiration here from sociology and those quite famous sociological experiments that were done with the Boston Symphony Orchestra when they put first violinists behind a screen, and so you could no longer see the gender of the violinist. Instead, we took an entrepreneurial pitch, so somebody pitching their entrepreneurial business, and then dubbed. You couldn't see them, so what you could see are the slides, and we then dubbed the voice. We took the script and dubbed it with a male and a female voice, and we used an online platform to basically ask people, is this investable? Is this convincing? Would you invest? This work was published in PNAS, and basically the results are fairly striking. Just to give you a sense of the other thing we did, we were looking at the role of attractiveness in some of these negotiations, and so we also superimposed images of attractive and less attractive men and women on these videos. And basically what you'll see from this graph is that there's a very strong attractive man effect. And I belied my age when I was having an argument with my co-authors about what we should call this paper and whether it should be, the George Clooney effect or something else. That was my own preference, but I was vetoed on that one. So this is the sort of example of how we can use these kinds of project-level studies. And you might say, well, what are the policy implications? I think as we think about the design of grant-making processes and funding processes, these sorts of things really matter. And places like the Gates Foundation and elsewhere have been thinking about this collectively with us. At the program level, we've done quite a lot of work understanding whether accelerator programs, as an example of a programmatic intervention that's particularly popular and fashionable these days, is really useful. Now here, of course, we end up with the classic selection versus treatment effect. So how do we get around that? Well, what you really need is a very clear rank ordering of all the projects or companies in this case that were interested in participating. And then we can use regression discontinuity to help us think about that on the margins. But you really need a friendly accelerator to help you make progress. And we were very fortunate to do some work with Mass Challenge. My graduate student, Dan Fader, who's just graduated, did some excellent work and really interesting work with them. I will spare you the econometric details, but basically the effect of the treatment, which is to be accelerated, sort of means that there really is a significant increase and a statistically significant increase in funding and employees in the sort of post-period. What this does is it really says, you can actually start to calculate how impactful a program like this is, and in fact, how much you're spending to get every additional incremental job and so on. And this, I think, has a lot of implications for regional decision makers, for foundations, for governments, for programs like RPE, for tax policies around these companies, for things like ICORP. And so a lot of this work is starting to inform those kinds of decisions. And the last thing I say is I think at the policy level, to pick up on this comment about whether we know enough about the effect of policies, this I think is a really important area, and a lot of my early work focused on intellectual property policies and licensing policies. And again, it's quite difficult to do this because many policies are anticipated, so you can't really pick up whether they were actually useful. So again, the economic apparatus that we would use for this is a sort of diffs and diffs approach, but we're often looking for policy shocks, so things that were surprising and unexpected. And some of my work looked at the rather unexpected agreement between DuPont, the NIH, and the Jackson Labs to make these transgenic mice available and to sort of pull back on the rather heavy imposition of the intellectual property rights by DuPont. So actually, in doing these kind of innovation policy studies, we're often looking for disasters or surprises or sort of natural disasters. So my colleague Christian Casalini looked for a moment when there was a great disaster and the French academics had to move out of a whole set of buildings because there was asbestos. My colleague Pierre Azelai has looked at the sudden death of co-authors to look at the productivity of co-authors. So he's not interested in co-authors who die a slow, lingering death. He only cares about the ones who got run over by a bus. So we're all a little bit macabre, I would say, in some of the work we do. But these sorts of techniques have been applied to other areas of innovation policy, like visa policy and non-compete agreements, I think to great effect because we really are learning a great deal more. So I'm going to skip over that and just say, so how do we bring any of this sort of out of the research journals and into the real world, and especially into the classroom? With a whole variety of my colleagues, we've been teaching a lot of this. So a lot of these things have course 15 numbers, but we often are very fortunate to have students from all around the Institute in classes where we explore some of these methods and these policy issues. There's a group of us have developed called the Regional Entrepreneurship Acceleration Program, where we work with regions worldwide to really share these program and policy insights. With MISTI, we've had a great collaboration so that when students go to do their MISTI internships, they're now what we would call innovation diplomats. So they get to think about the innovation ecosystems and in places that they're going. And I guess for me personally, it's been very interesting to bring some of those insights to bear in the Prime Minister's Council in the UK, where quite often I find myself telling some extraordinarily distinguished scientists and engineers who are so thorough and scientific in the way they think about their actual scientific and technical work. But when it comes to these more organizational and policy questions, they'd much prefer to tell stories. And so I quite often find myself saying, well, we actually do know stuff about that. There are facts on the ground, and there is social science research to help us. And that's been a very interesting learning experience for me. So with that, I should acknowledge a whole variety of my colleagues and former students, TPP students, and others who've been very important in this work. And I think there's so much more to be done. But I just want to say thank you.
Thank you very much, Fiona. And actually, I want to thank each one of our panelists. And I certainly was quite enamored with what some of my colleagues said. And so I want to build on that and say a few words of my own thinking, which I've been working on. And then hopefully we can have at least 20, 25 minutes of discussion. I think what you call Erica, and very appropriate for MIT. I actually used to have many arguments as I went into the STS field. Technical details do matter. That knowledge is important. But again, what Kelly, however, talked a lot about, she was in some ways, even though very successful, lonely in Washington. And then on the other side, social science matters significantly. Okay? And then, of course, Fiona was on the subject of innovation, and really where creativity, something which I want to highlight again. So I think, and actually, to Kelly, I would also add political science. And so I'm a hardcore technologist and physical scientist. I spent most of my career at Bell Labs. For me, that's still the greatest place on earth. Even though Harvard and University of California, where I work, were all very great. But nothing was comparable to that institution. And I would say MIT is close to that. Okay? And so but at the same time, when I went to the Kennedy School, having served in administration, I was interested in public policy. I happened to be doing my sabbatical. I'd go once or twice a week to the Kennedy School, attend some of these ETIP ones, which Kelly and John Holden would organize. And then I get a phone call that John Holden is going to Washington, and I ended up at the Kennedy School. The Kennedy School has been a very opening experience for me. It is the opposite of MIT, opposite of many other parts of Harvard. But I can tell you, just like MIT has enormous pull, like Bell Labs in the world of technology, Kennedy School has enormous pull in the world of politics. Literally, who is who in Washington and globally. China, India, ministers will say they were at the Kennedy School, and yet I taught there, and I shuddered because we were training public policy leaders who didn't have a clue about technology. So this is the kind of thing which tells me about the experience of, if Kelly had that experience, I would have a much worse experience, because Kelly is a social scientist with great social skills, and so that really bothers me. So that tells you the divide which we face. Another thing, I decided to collaborate very early on with Sheila Jasnoff, who is a noted STS scholar. In fact, I said, we'll hire a joint postdoc. She and I would have arguments. I said that person must have a science and engineering degree and also a social science and STS. I said, they're the only ones I'm going to hire. I got her convinced on that, and she would say, oh no, we want these pure social scientists who can look at science objectively. I said, no, you have to know those details do matter. And I would remind Sheila that she was one of the most interdisciplinary scholars because she had her undergraduate in mathematics from Harvard. She had a law degree. She had all that training, and she tended, and not to forget that. So I think we'll come back to how we educate. I actually believe engineering, that's how I convinced Harvard that they need an engineering school, is an ultimate liberal art. We need to change that and not just be, quote unquote, the Bell Labs nerd or the MIT nerd. And liberal education must involve technology in a significant way. At the Kennedy School, one thing, Nick Burns was my neighbor, his office. You know, he was undersecretary, ambassador, and so on. Very articulate. You see him all the time on public radio whenever there's a crisis. He says, Venki, I was negotiating with India on the 123 agreement. I had no idea what the fuel cycle or any of those things meant. And not that I have to be a nuclear physicist, but just didn't have a clue. And many of them agreed that, in fact, that needs to happen. The reverse I've learned about engineering, that we too often don't have a clue that to succeed, technical systems are social technical systems. Unless they integrate well with society, they're not going to be successful. And that's why those issues of diversity and all that. I'd like to show a few graphs because the subject which is really dear to me is the subject of science and engineering and invention innovation. So could you provoke one or two of the view graphs from my... I don't know how, hello? Yeah, is it possible for you to? Otherwise, I can just go. I want to say that we want to change the language. So I've been writing a book because I think Kelly mentioned that economists, and you know, Harvard and MIT, two economists, Schumpeter from Harvard and Robert Solow at MIT, wrote literally the book on technology and innovation and creative destruction and all the other features, et cetera. And economists have written about national innovation systems, Nelson, et cetera. And you find that, in fact, and many social scientists, Roger Pilkey wrote to me after I wrote a paper, Venki, you're completely right, but the whole thing is a political symbol. Unless you change the politics, you're never going to succeed. And so I wanted to discuss this a little bit because I felt very passionately about Department of Energy, where I worked as vice president of Sandia, and I learned about the bureaucracy. So I start my book on the discovery and invention cycle. I'm very much against the fact that engineering is applied science. For me, engineers are the creators. They imagine and change the world. Lots of people right here at MIT. So it is not a derivative. It is creativity in its own right. Science is about understanding, and your understanding is important. And the two sometimes the invention comes first, sometimes the science comes first. There is no pecking order. Thank you. So I've written this book, and that made me learn a lot about history of science, history of technology, and where technical details matter, Erica, the fact that I had been intimately involved with that post-transistor era at Bell Labs showed me how science and engineering, how discovery and invention were related. If you look at the Nobel Prizes, it turns out that in the early days, they were all for great inventions, from the X-ray tube, et cetera. And overall, after a while, everything was ascribed to science and scientific discovery. Transistor was called a great scientific discovery. Actually, the invention of the bipolar transistor and the junction transistor was first, and then led to all kinds of other kinds, and so on. And the laser, you can argue, is the laser a discovery or an invention? Okay, so I think somehow the word invention got forgotten, and now slowly it is coming back again. It's not something which MIT needs education, but believe me, Harvard needed to it. We had not a patent. Okay, so I start my book with what is today. The instructor said, let's worry about the grand challenges. And in 2015, there was an article in Science magazine where Ernie Moniz appears before the House Committee on Science and Technology, which actually administers the DOE budget. So the Obama administration requested a 5% increase for the Office of Science and some 15% increase for the Office of renewable energy. And Ernie Moniz got taken to the task. He says, oh, Obama administration doesn't care for basic science. Why are you funding all this applied work in energy? Ernie does a very credible defense. Sir, we have to fund the entire innovation system, and this is necessary. It comes back. I have trouble with this administration, that says, because you don't care for basic science. In my mind, that is the nub of the problem, and the origins of it was the famous report by a Harvard PhD, Dean of Engineering at MIT, and perhaps one of the most famous names in science policy, Vannevar Bush. Now, I do regard him greatly. He was at a different time, but in Science, the Endless Frontier, he basically said you separate basic research from applied research, make a wall between them, and the DOE program managers. I sit on 4 advisory boards of energy frontier research, including the one at MIT. I learned materials. But you make materials, you understand the physics, the chemistry, and everything else, and you make something out of it. That's how I learned physics. That's how I learned engineering. The DOE program officers, don't make a design. Don't make a photocell. Don't make a thermoelectric cooler, because you're doing applied work and you're funded by the Office of Science. You never separate it like that. So these poor guys obfuscate. Don't call it a device. They call it a program or some other way to satisfy the program. So Bush's paradigm is being applied through economics and by program managers, even though Steve Chu said you should actually have this integrated effort. It's a serious national problem. So I have done a history of kind of different kind of words which have been used: applied science, basic research, fundamental research. You know, Bell Labs in 1947, the same time Bush was being created, had a different model of research. There you never had different kinds of research because they felt the word applied was derogatory. And in fact, they said, he told Bush, if it's not pure research, is the rest of research impure research? And so he called the word basic research. And if you did an engram, you find the word basic research peaked a lot after 1940, even though national innovation models had changed a long time ago. So that's sort of a very short thing of where I'm coming from. And Science, the Endless Frontier, the language needs to be thought through. So I went back and read articles in the Bell System Technical Journal. I thought I'd been a great dean and everything else, and I felt humbled. All these guys at Bell Labs had thought about everything I had thought about, and I was just reinventing the wheel. So I got really humbled by reading the Bell Labs literature. The vice president of research at Transistor said, we do not separate research into different categories. Research is an unscheduled creative activity which has no schedule because you don't know the answer. It might involve science, it might involve engineering, new invention, all kinds of things. Development is a specific activity, specific time frame with milestones. They do not have any such category as applied research because research is the category. So it is changing the language is extremely important in this matter. So that's really the message. So I want to not go through any more and start a discussion. We really need to fundamentally change how institutions work. So I found that when I had a short paper, Roger Pilkey wrote to me, Venki, you're right, but it's all the politics. Social scientists told me the physicists drew the boundary, engineers draw boundaries too, social scientists draw boundaries too, and I discovered at the Kennedy School, I tried to build an interdisciplinary group. I had a political scientist, lawyer, computer scientist. And this political scientist in my group writes this big article on cybersecurity, which I hardly could follow. I said, my English is reasonably good. What are you doing, Lucas? He says, I'm looking for tenure in political science department. Unless I write in this way, I will not be accepted by the political science department. So I've discovered that the social sciences have become so specialized that only 4 people, and even a person who went to a liberal arts college, could hardly understand the language. We fundamentally have to change this language. So I tell Sheila, your STS work is great, but you never quite related or teamed up with the practitioners and bridge theory with practice. Same with social science. So there are problems, and the engineers who just never heard of anything. I chair an academy panel. they've never heard of Pasteur's quadrant. That's the only social science paper which actually impacted policy. And that too only recently with rising over the gathering storm, etc. So one has to ask the question, we can do all the social science, we can do all the political science, we can do all the technology, does it all impact policy? Unless we learn to bridge those divides, it's going to be hopeless. So I believe the language has to change and in fact, really bridge some of what the three of you were saying and my few cents of what I wanted to say. Let's open up for discussion on this subject. Yes.
Well, you touched the elephant in the room. It seems, coming from a science background, social science seems to be jargonistic and they're trying to cover up lack of depth. I'll put that broadly. I know I'm wrong, but you've seen those studies where people used a computer to generate nonsense and they were accepted in journals. What can one do to move that forward? I know I'm unfairly damning the social sciences, but I just want to put it forth there as how do we solve the problem you presented?
I actually think there needs to be a fundamental restructuring of our education systems. That's because now working, having been both dean and a faculty member for 20 years, where you teach and what you teach grounds you. The research is obviously important, but how we are educating the students, I can certainly say in this Division of Engineering Applied, so we care a lot about education. We are teaching our students very differently today than we were before. The culture needs to change significantly. I give some examples. People would write to me, Venki, you're dreaming about Bell Labs, that was gone, it's dead, you can never recreate it. It's like saying we'll never recreate another MIT and so on. I don't believe that. There has to be an MIT 2.20, Harvard 2.0, Bell Labs 2.0, 3.0 for the current age. And so we, the universities, which I thought need to develop a very different culture. Every university will say, we do interdisciplinary, we do multidisciplinary, we do transdisciplinary, but not many do, because they become the social science boundaries. The department doesn't want to share its resource with the other. If I give Kelly in social science and give somebody, so somebody up there has to change that. This includes the culture. So one of the messages which I learned through becoming an STS student, even though data and all are important, Erica, I personally discovered in all of my analysis of institutions that culture is really crucial. So the Bell Labs people had developed a certain culture. I went to Santa Barbara, there's a certain culture, and I can't take it. I was only one of the deans, but there's a whole history how this happened. So, and MIT has a culture, and of course there's not a one culture everywhere, but paying attention to the culture is very important. Policy, State Department people and policy people just write some policy papers without paying attention to a whole lot of other factors which are really important in this matter. Yes?
I noticed on your slide,
yeah,
you don't have a word like tea. And I noticed you don't have a word like tea in your T-E-A-M.
Oh, yeah, yes.
And I think, I'm an engineering academic here at MIT in the technology and policy program, as well as in engineering and engineering science.
Yeah.
And I think there's a real change happening where the value of all of us working in teams, students, faculty, colleagues, it's really becoming apparent how much better that fits the key words that you do have up there.
Yeah.
And I think academia is slowly coming to accept that that is how really insightful research will be done in the future. Could you comment on that?
I think others here should comment too. You're making an extremely important point. In fact, I'm currently on a project with Sandia National Lab because my only hope is to change DOE because Bell Lab had a tremendous scale. MIT has a tremendous scale. That's why they're able to do certain things. Innovation is very important, but they don't have the scale of the kind of stuff which I'm talking about. Some energy problems require the scale. Fundamental restructuring has to occur, how we do our work. So team science, team engineering, team research rather, is really important. Because in fact, disciplines require that. That's what transparency, and then how you reward them. Our reward system is so individually focused. God knows, I'm reviewing China right now, and they've got a data system where if you have one paper, who's the first author gets so much credit, and maybe the rest of them get no. That destroys it completely, of course. So and in academia, it's full. Yesterday I was at the Roland Institute reviewing them, and one of my Harvard colleagues says, oh, he isn't first author enough. He was a wonderful team player. And this is a problem. High energy physicists, some of them have learned. Some parts of Bell Labs learned it. Bell Labs always had very small groups, which forced you to work with somebody else. Bob Dines and I wrote 40 papers. He became president of the University of California. And he and I said, we won't argue whose idea it is. We'll flip a coin. We'll work together. And we'll alternate as first authors. So this whole area, we have to develop a culture of team science or team research. And the reward system has to be so adjusted.
So I wonder, actually, on this exact point, Venki, and to address both of the questions that were raised, if you bring together people around essential, critical, real-world problems, you're going to have to bring the right people to the table. And when you have the right people at the table, then they're going to disagree with each other, right? And so I think if we, absolutely, by definition. And so I think when we're thinking about what are the important real-world problems of our generation, that are, or the next generation, it's without question going to be human health. It's without question going to be climate change. It's without question going to be the digital future. When I'm working with several of the machine learning and computer science colleagues, and I'm asking them when we're working late at night what they're doing, they're online doing sort of like cyber warfare between the good guys and the bad guys, and someone's attacking a bank, and I'm like, wait, we have a grant to submit? What are you doing? And they're like, well, no, someone's attacking a bank. I mean, that world that needs to be addressed, right? I said, isn't someone regulating that? I said, no, I gotta get in here right now and do this. So I think the question is, can you bring the right people to the table? And frankly, in the National Academies Committee I'm serving on right now on ARPA-E, it's half social scientists, half engineers, and to see those debates play themselves out, is that even the right committee that you've brought together? The key is who you've brought together at the table at this point in time. But I think that I've named two issues, human health, climate change, and then the digital future. I think two more that are facing our generation that have deep technical issues, and the next generation. The one is the future of work. What that is, given technological change and where that is going, is an enormous problem that is going to be deeply interrelated between policy and technology, and is going to require government decisions. And the other is the global rise of demand and production in developing nations. So over time, we're seeing more and more manufacturing happening in developing nations, driven by the exponential rise of production and demand, largely in China. And when you look at that, right now in many, many industries, the largest source of demand is China, and the largest location of production is in China. So what does that mean for what the incentives are for global companies in order to create the next technologies of the future? Are those incentives good for the world as a whole, for society as a whole? Are they bad for the world as a whole, for society as a whole? And I think when you think of the questions Kelly is raising of we need to move beyond national innovation systems, possibly, maybe not. I'm not going to argue that one out. I think there's a question of how do we start to address these global incentives.
So I think that adds to just want to add one word to you.
Please.
That's why we need really important diversity in its finest sense being involved, because technical systems are social technical systems, not just the women involved, and what clearly saying that we want the international workforce, which are defining elements. So it's only adding to what you're saying. I just want to add that word, because it's important. We tend to forget that, right?
Can I jump in with one quick response? I can't let it go. I knew you were talking to me. I mean, I think there's some great social scientists out there, and of course there can be rigorous social science that's done, but I don't think you're going to find them in political science departments, and I don't think you're going to find them, for the most part, in traditional economics departments. You're going to find them in subversive programs like TPP or engineering and public policy at Carnegie Mellon, or business schools, or the policy schools. You're going to find them in places where people are allowed to take those risks, and publish outside the traditional journals and so forth. And what I was trying to argue is that those subversive programs really need to encourage social scientists to come there. Because I think, I would say the preponderance of people are more on the technical side and sort of coming to the social science. When I was running the ETIP program at Harvard, everyone who came to us basically came from a technical background first and then said, we want to learn about policy and do something about policy. But I think we really need to be fostering and training in a rigorous way people coming from the other side too, to be able to bridge and be part of these teams.
Yeah.
And I still think that there's more work to be done.
Ideally, having a joint degree really does help. It's complicated. And so, in fact, at least the few I've hired, they were both had and actually kind of PhD in STS or social science. And that combination really turns out to be quite important here. Yes. And please, Director too. Yes, go ahead.
Did you want
Fiona.
to?
I'm going to let other people ask.
Okay.
So I actually want to build briefly on Kelly's comment. So I take a slightly different take on that just for the moment of debate. I actually think that there is phenomenal work happening in the social sciences, not even in the, not just in the subversive groups, so to speak. And I would say that it's the melding, it's the conversation across those two that is essential. So it's not that, so I've now had the incredible opportunity, in part because of how Carnegie Mellon is established, to co-author with a machine learning expert, to co-author with a statistician, to co-author with an econometrician, and to co-author with an industrial historian. And in each of, and to co-author with Granger Morgan, who's a physicist, right? So I think that in each of those cases, it was in bringing us together that we were able to do far more than we were able to do alone. And that's just, I believe, to answering these world problems is what needs to happen. And I don't think that has to happen. Yes, Carnegie Mellon, you could call all of Carnegie Mellon a sort of a subversive place. But I think that this is happening across the country in a variety of contexts and the opportunities to do
that's
more
what we
of
call.
that.
But Fiona, we want a subversive element. Because in fact, UC Santa Barbara was subversive. There are others who actually will change it. And so you as an innovation czar, so to speak, should give us some guidance on that. Because I think we do want that subversive element.
Well, I'm sure that Vladimir and I were chosen to lead the innovation initiative here at MIT because both of us are subversive in some way. Neither of us have MIT degrees, which itself is, and neither of us are actually from the US. So I think it's interesting how there is diversity on so many dimensions. I mean, I feel obliged, even though I'm not in the economics department, to say that I think some of our colleagues in the economics department do extraordinarily good work. And I think that a lot of what you're talking about with sort of gobbledygook sort of happens not at the highest level. So if you look at the sort of highest level of research in any institution, in any discipline, you get extraordinarily good work. As you sort of move down the quality curve, I think you end up in this world of sort of nonsense. And I think what's particularly problematic about this whole issue of team science is that we need to educate our students to be able to understand these huge grand challenges and come at them from many disciplines. And yet, if we want them to go out in the real world and be productive, then I think actually having that interdisciplinary education is extraordinarily powerful. I think to the extent that we then want to educate them to be in academia, academia hasn't caught up in terms of the way in which we reward people. And so we're simultaneously needing to collaborate, and yet we have to publish in narrow disciplinary journals that require you to write inside. It's sort of a form of insider baseball. And I think that's the challenge. And I'm not sure that there are any straightforward ways to improve the tenure process. I mean, around the world, people engage in sort of counting and citation indices and money for being a first author in certain countries. I think that whole thing has to change. And the only places where that seems to change is in, again, the most elite institutions who can trust their own judgment and the judgment of their peers rather than having to count. Yeah. And I think that that's a huge challenge for us to sort of contemplate how we then create reward structures. Now, this is not a new discussion. I mean, we've all
That's
been...
big. Places like Harvard and MIT can set the bar in this way, very important, because they have some self-confidence.
Yeah.
Right. David?
I have to add Carnegie Mellon.
Carnegie, of course. I have to add Cornell. Yes.
So since you were offering definitions, let me ask you a definitional question. In certain circles, the word innovation is associated with small business venturing, entrepreneurship, and startups.
Yeah.
And I'm curious whether you think that's an appropriate scoping for innovation or whether that's a narrowing of innovation compared to the definition you offered up here.
I do that. My own, I think the economists have various definitions. My definition of invention is very different, the very early phase of the thing. And of course, innovation is when there's broad impact. But so small business could also eventually have broad impact. But I think invention, innovation, discovery are often confused. So my view simply is this, and that does not mean it's the only view. I mean, you might have a,
Well, when we teach innovation, should we be teaching something beyond how to start a company?
Yes.
Yes, yes. Most definitely, yes.
Can I just pick up on
And
that?
we
So
all
I-
agree on that, don't we? Yes.
I think we have to. I mean, I think that, one of the reasons why MIT had decided to have an innovation initiative, not an entrepreneurship initiative, is an extraordinarily important thing. I think that the innovation process and this whole sort of transformation of ideas to having impact can happen in a wide variety of organizational contexts. And we sort of all know that. I think at the moment, both the most fashionable context, the one that's most sexy to our students, and the one that is, I think, important in today's economy, are the high growth potential startups. But that doesn't mean that large corporations aren't extremely important, that universities don't still matter, and even not-for-profits. And so I think we should remain organizationally agnostic. We have to teach that you can design an organizational form just like you can design a technical system, and we have to pick the best one for the job at hand.
By the way, David, for people in this audience, Brian Arthur has written a wonderful book a few years ago, The Nature of Technology, which actually goes through some of these very interesting questions of how actually technology evolves.
And just question there. Can I build quickly on Fiona?
Yeah.
Just a very brief build.
Okay.
I think the tension between the fact that recently there's work coming out from the U.S. Census Bureau showing that small firms are essential to job growth recovery after a recession.
Young firms, not
Young,
small firms.
thank you, young firms, very well corrected. And indeed, there's an explicit debate on that.
Yeah.
And then at the same time that it was the Bell Labs that led to large-scale inventions, innovations is a fascinating question. That faces our time.
And in the energy space, you actually hit it. Some things small kind of works, and some things you really need scale, huge scale. So it's not an obvious. So there are several questions at the back, right there.
Good morning. Thank you. I want to take us maybe in a slightly different direction. The conversation and the outstanding caliber of people here give me great confidence in the ability of MIT and the related institutions that you all represent to address these grand challenges, to do the interdisciplinary work. This is sort of addressed at Professor Sims Gallagher. I get very concerned with what I perceive, and I'm going to oversimplify, the tremendous gulf between this kind of conversation that can happen at a place like OSTP and the kind of conversation that happens between 300 million people and their legislators in the public arena. How do we, as individuals who deeply care about addressing these challenges and feel like not even that we have the answers, but that we at least have the ability to work together to try to develop solutions, how do we even begin to get a society that doesn't seem to value even the dialogue and the discourse about, I'm not even using, not facts, but just something tangible that's removed from 15-second sound bites and emotions? How do we bridge that gulf? I think that's ultimately going to be the meta challenge of addressing all of these challenges.
Oh, I wish I had the answer to that question. I obviously, working on the STEM education side, I think is tremendously important. And I take a lot of interest in what my kids are studying in school and why aren't they talking about certain issues and what, it is kind of interesting, but I am no expert in that area. I think the other side, though, of that conversation is with the legislators or policymakers themselves. And that's why I was trying to make such a strong pitch for people like you to go in and serve, because it's just a constant education process when you're there. Of course, you're constantly learning too, but you're doing a huge service to just say, you might want to consider this fact. You might want to, did you know that, in Europe they're doing this, or in India they're doing that? And just being able to be there for those conversations is so important. It's hard, and for me it was kind of a painful process, but I think that's really important too, because these people are in leadership positions. They have a lot of dialogue with their constituents, and so that's an important thing for us all to do. And if you can't actually go serve in the government, taking the time to have those conversations with policymakers, do the briefings, make the trip, it needs to be done in person, is really valuable, and I think can make a big difference.
To 100% agree with what Kelly said, and then add, and to train our students to speak in 15-second sound bites.
I think there is currently an American Academy panel which Dick Meserve and also is co-chairing on the public face of science. Others are worried about it. This is kind of important. And in our country right now, facts, it's partly true for climate, facts don't seem to matter, because in fact, whatever somebody says seems to be it. And so how we actually counter that trend is really a serious problem. So I had put up this slide at the end, which somebody referred, because grand challenges are referred to. Lots of people at National Academy of Engineering, environmental area, many of them have emphasized some of the key characteristics of such things, especially the National Academy of Engineering. And a person here had said about team science and team research, really. And I really don't want to make science synonymous with research. Research and science are different. Science is very important. Engineering is important. Engineering technology. So research teams is really important for that to succeed, to solve the grand challenges. And they exist in health, in biology, medicine. And it turns out that the biology discipline, when I chaired that academy panel, is even more stovepiped than engineering or physical science disciplines. Extremely stovepiped. And in fact, pharmaceutical companies are in great stress because drugs are so expensive to make, and they just don't. Translational medicine is a huge problem and extremely important. So I think the whole bit of culture changes has to occur. Again, in my book, I mentioned President Obama has the BRAIN Initiative, and it turns out it's a wonderful thing, nationally prominent, but there's an NIH, NSF, they're not really integrated. I've commented on that, and in fact, if you look at the committee which the NIH formed, there are very many distinguished neuroscientists, but there wasn't an engineer, applied physicist, leave alone social scientists, and that's a serious problem. And so I asked this person at National Research Council, what are you doing? He said, oh, we'll have them as consultants. The whole place broke into laughter. So this is a very serious issue of leading change and integrating this. So I think our time is up. We've got 1 minute. If somebody wants to have a closing statement,
I think that's
maybe our
-1
chair.
minute, that's minus 1 minute.
Huh?
It's counting up.
You've gone into negative time.
Oh, we're negative. So we're negative. It is 10:30, and Jessica, you are in charge.